They do have a style sheet. It's got tons of classes. Look at this span element. How do we turn it into a rectangle and put it on the screen? Hey, I'm Tyler. I spent 2 years building my own calendar app and studied Google Calendar religiously. Now I'm explaining how it works behind the scenes. Let's go. We gotta start with the big picture. So this is a basic architecture of the app and its resources. We have assets like images stored in cached storage in the browser. If you enable offline mode, calendar data is in indexed DB. We're also pulling stuff from Google's CDN called gstatic, like fonts. JavaScript files are making requests to an API, of course, and that is mostly the Google Calendar API. And also some other ones like contacts, meetings, auth, and each of them have their own data store. Finally, we have services that are also calling those APIs without you directly doing anything to check that the app is still alive, for example, to synchronize with other calendars and to time out how to notify you. We're going to spend a little extra time getting a lay of the land. This is the prettier version. Noteworthy changes. All data stores are Spanner, which is Google Cloud's distributed data store. Next, this is like a look into one of these services. There's a CDN in the front and a gateway. Then it gets into the microservices, and we have a few other ones I didn't mention, auth and FreeBusy. And then the API, like the Google Calendar API, would be coordinating between these types of services through PubSub. That's how they access your event data. Your caching. This is Google's caching now, which they use Redis for. We have some protocols here. It's secured back and forth from the edge. Mostly REST. PubSub is when you're publishing and subscribing to things like a notification service. You can look at the SQL and writes here. So a little more on implementation details. And in the last diagram here, this is like a workflow on how the notification service would play into an actual use case. So you got one-on-one with your boss, you get invited, you accept, then the data stored. Google is using their event service to notify you 10 minutes before, 1 minute before. That's when you get your email. Time to dig into the code. Here's the HTML, JavaScript, and CSS that brings it all together on the UI side. They do have a style sheet. It's got tons of classes. They use class names heavily, and then they target those class names in their JavaScript. Old school way of doing it, but it obviously still works. They are using the fonts called Product Sans and are both developed by Google. They do not have a framework that I am aware of. And what I mean is something like React or Svelte or Vue or Angular, things that have come about in the JavaScript community after Google Calendar was built. I would have guessed it would have been Angular, but I don't see it. I don't see any signs of it. Instead, I think they're just using JavaScript, CSS, and some homegrown solutions like Rawdog. They have a JavaScript compiler they built called the Closure Library, which improves the speed of common JavaScript tasks. They are using a phone number parser, which is open sourced, to parse phone numbers. But mostly, it's just JavaScript. They chunk their bundle into 28 different JavaScript files. They're minified, and they do a good job of obfuscating the IDs. They're not the same across different bundles, and you can't hack into them as easily. Look at this span element, for example, and how much work they're doing to come up with the accurate name for it, the class name for it. Now it's time to talk about the HTML, the old markup. Any calendar app is going to have a certain hierarchy. There's going to be an all-day row, a main grid, and then some other layers. The main grid will have rows and columns, and the all-day row is one big row on the top. The other layers are for things like letting you drag things on top of it, toast messages, or those pop-up things that you don't want just contained within the calendar grid. So that's what we're seeing here. There's the event dialog goes on the grid like a smaller one, and then that full page one, it's there to focus on creating the event. We have the settings page too. Now we're going to talk about cool JavaScript stuff to make this work. We have our grid, and we know events look like this in terms of the data they're provided. How do we take this stuff and turn it into a rectangle and put it on the screen in the right place? There are two main steps to do that. You need to calculate the shape of the rectangle and then calculate the X and Y coordinates to place that relative to the screen you're looking at. You get those values through a combination of measuring the DOM, calculating how many minutes an event is, and then dividing that and routing it based on your current time interval. Google does it in 15-minute increments, for example. All while being aware of some edge cases like events span multiple weeks or overlapping events. This is how they're doing it. If you're curious to dig into the algorithm stuff that makes that all work in like a very detailed sense, you can check out my open source version, going to this repo and searching for the get position file. Google Calendar does the same thing. Another interesting problem is when two events share the same times. You don't want them to hide behind each other where one blocks the other, and you have to come up with some way to make sure they're overlapping but are also both legible. I studied the UI and came up with this pseudocode. I prefer how Outlook does it. The difference is Outlook is like squishing it all into one column, just making the events length narrower or shorter. I think it's a little easier on the eyes, but Google's coming up with a unique way to overlap things. They're both respectable. If you want to look at the code, the pseudocode, pause it, check it here. That is another interesting problem. They've done a good job with it. Here's the quality of the code based on Lighthouse scores and my review of all the source files I could see. Their accessibility is pretty solid and their performance is not good. However, I want to give them a pass on the performance piece because they're not trying to be really good at performance. They're trying to be stable, reliable, and easy to understand. There are a lot of things that you can see they're not implementing, but it's not like they're trying to do it and just failing. They're just not doing it. When I've looked at this JavaScript code, I see good practices, consistency, cleanliness. It's just old. They're not going to compete with modern techniques, tools that have really good scores. A small confession, the first score I showed was from 2024. It's been 2 years, so here's the updated score, and it actually went down in a lot of the dimensions, which furthers my point about it not being a high priority. We're going to contextualize that even more at the end, but first let's look away from the client and towards the Google Calendar API. I'm going to give a hot take about it after studying it. The team has been phenomenal at just saying the hardest sentence in the world, no. Use a front-end framework, nope. Use TypeScript, no. Use a trendy CSS tool, no. Class names, use a native desktop app, no. Browser, give us dark mode, no. Make it really fast and accessible. Nah. Their commitment to this has allowed them to still be dominant despite so little investment in this product. However, on the API side, this tendency comes back to get them. But really not them. Let me explain. Imagine you're young, naive, you like calendars, you want to build your own calendar. You're going to call it Cool Calendar. And to make it easier for new users to sign up for Cool Calendar, you're going to let them sign in with their Google account and bring in their existing events from Google Calendar. So of course you're going to check out the docs and you see it's got what you need. You can get users, events, calendars, all good. Hook that up together, put it in a big function, call it import, and voila, you have all the events from a user's Google Calendar and you're stoked. You're getting ready to celebrate at Denny's, and then you realize, oh crap, this is just one way. You're going from Google to Cool manually. Like you're running the function yourself, but you need to go from Google to Cool whenever something happens. But the problem is you don't know when something happens because it's happening over there in Google Calendar world. So you're like, there's got to be some solution to this, two-way syncing thing, resources. Then you find a doc on the Google API site. You're like, sick. It's short. It looks pretty straightforward. There's even some code snippets. I got this. You play around with it a bit. You convert the snippet from Java to JavaScript. Now you have events going from Google to your app as like an import, but also as like a sync. However, you realize it's not that simple anymore because you have that function again, but when do you run it? When do you know? You don't know. You know you can sync events. When are you supposed to sync it? Every hour? Every minute? Okay, they say this is all built around like this token, this next page token or sync token. And it's like, okay, where do I put that thing? Is that in the browser? Cache, local storage? Is that in my database? Will they do that for me? What is this token? It's magic token. I'm stressed out about the token. Well, if I lose the token, what if it expires? What's in the token? You try poking around the token. You can't see anything about it. It's opaque, as they say. Okay, say you lose it. Can I keep trying to get a new one? Will that result in me hitting quota limits? I heard that's bad because then the API rate limits me and that's not good for anyone. Do I have to do a full import? You're seeing all the things you overlooked. Now you're pissed because you realize you might not be going to Denny so fast. We move to the next phase, bargaining. I'm not alone. I can reach out for help. Repeating your therapist's motto for you, and you're confident the docs have something for you. Some other company has something for you. Some Richard Stallman disciple created a repo MIT for you. Nope. The docs are bare. The YC companies are making agents. Stallman doesn't like your app because it's for profit. There's no one else there but for you, and you have to code it. So now you accept it. You're like, all right, let me engineer it. Let me actually do this. You're going to take on the complexity. Now let's dig into what that looks like. Thankfully, you figured it out. Cool Calendar's up and running, featured in TechCrunch. Now you're the hottest guy in the valley and on podcasts. However, you keep going to sleep thinking, did it have to be this way? Did it have to be so hard? Then you remember the current theme of the Fullstack engineer program is architecture. So you're like, let me be an architect. Let me put myself in the shoes of Google Calendar people and reverse engineer what the product requirements were for Google Calendar's API sync feature. Dig into the solution they created, and then finally you can assess whether it did have to be that way or not. Bear with me, this will be fun. I know it doesn't sound like it's gonna be fun. Here we go. Requirements doc in the form of a product requirements document. The Google API has to push notifications when someone makes a change in the Google Calendar app to the people who said that they want to hear changes from it. Clients need a way to hear from Google through pushing so that they don't have to poll and use up a lot of resources unnecessarily. They also need a way to incrementally sync, so you can't do full-on syncs for everything every time one little time changed. Other than reliability, we have to handle some edge cases like what happens when the event is gone, what happens when the client is offline for a while and missed a lot of stuff, what happens when the user revokes access to OAuth for the app. What does the client do with their data? How does that initial full sync work? What are their parameters around that? The main things to think about are how do we let the client know something changed, and how do we give them the building blocks to get that delta or the differences for incremental sync. So imagine that's one team. Those are the product people or the high level engineers. Now this is this other team who's like, okay, I see those requirements and here's my answer in the form of a technical design document for how the sync API can be engineered. It's built on a couple foundational principles. One is a next sync token. It's just a token, like a string. It's opaque to the client. They don't know what it is. This thing is going to make sure we can give them the delta, because we have that token on our end. They're going to give it to us, and then we'll say, hey, here's everything that changed in between the last time you heard from us. They're also going to hear from us via webhooks. So they're going to subscribe to a webhook or watch a channel, and then when something changes, we're going to post an update on that channel. Let's look at a flow. Cool Calendar calls get Google Calendar. We do that in a loop using page tokens and cursor-based pagination, not offset-based pagination. At the end of all that, we're going to get the token, store it in our local somewhere in our database, not in the browser. Next time we can use that token. While you don't have the sync token, keep looking until you get the sync token, and then you save it in the user settings, for example. Here's an interesting part of the equation, the webhook. This would be the payload returned from Google when they're like, hey, something changed. That's all they basically say here. They're not like, this changed, that changed, these are how many changes. They're just like, hey, something changed. Your events changed on this channel. You post on their watch endpoint. They do checks. They let you know when something changes after a user makes a change. And they publish it via webhooks at a post endpoint for your API. Then you say, okay, I got it, cool. Then you have to go back and be like, hey, what's new on this channel using the sync token you got from before? It's a 3-step process. Get the sync token, get a notification something changed, and then get the new stuff, and then you got to handle the new stuff. And that's what this is about. That's the basis of what these Google engineers have come up with how to make their API allow users to synchronize their client calendars with Google's calendar. Man, that gets me fired up seeing all this stuff. So I hope you like this stuff, man. Let's move on to analysis. To oversimplify, Google's response to the prompt of letting users sync their stuff back and forth is like, hey, give them a token and let them figure it out. Was that the right move? The strengths of that are it gives Google a lot of flexibility to update their implementation without breaking things downstream for clients, because they don't have much to work with a token. They can't, for example, if it were a string based on start time and end times, then you open up a lot of worms with time zones, offsets, daylight saving, like, oh, that gets messy. With the token, they can change databases, which they did from NoSQL to NewSQL in their move to Spanner in the 2010s, without even concerning these other people using their app. It also lets them handle deletions a little easier. They don't have this contract saying, hey, you can have stuff up to this point. It's kind of like, you get this token, it might come back with a 410 gone response, and you need to know how to handle it. And that gives them a lot of freedom. The weaknesses is that, as you saw with the 3-step process, the push notification is separate from the incremental sync. It's another step of complexity for the client. How to get around this? Why not include the little diff, metadata section, where you at least get the IDs. If it's under 10 IDs that change, you can just get the IDs and save a little bit on the second call. Another thing that makes it tough is when something changed, you can't use like a min and a max parameter. You can't say, hey, just let me get changes from the last 2 weeks. It's either min and max or the sync token. You either get the delta, the changes, or you get it from a point in time, regardless of whether it changed since the last time you looked at it. And that's restrictive. So a lot of the times with calendar apps that integrate with Google Calendar, they're laggy in syncing the data. They have to merge changes, reconcile things, do optimistic checking, changing, pruning. They're doing a lot behind the scenes to make it seem like it updates quickly. And it's because they don't have the tools to do anything different. You kind of have to do it that way. Also, if something goes wrong, you got to start all over. You got to do the full sync, and there's no partial recovery. So what are some other things they could have done? Instead of cursor pagination, they could have done offset, which looks kind of like this. The problem with that is calendar data can change a lot. Even in batch it can change, so offset isn't a good use case for that. If they went with a timestamp delta, the request like I mentioned before with updated min. Not only would that be hard for clients, but Google would have to worry about synchronizing across different shards. What happens when the clock skews? What if there's race conditions? Using timestamps in requests is just really hairy. So they didn't do that for good reason. What if every event just had an e tag, which is like a string where it says this is the last? It's kind of like its own token, but at an event level. I don't think it fits the use case of getting everything that's changed since last time. You don't want to go event for event. I don't think most clients would need that. So leaving it out makes sense to me. What if we did like a feed and used a sequence number, let the clients fetch easier? That gets really complicated. And what if we just pushed based on the webhook connection? What if the client's down and they don't respond? Then you need some way to catch up, and now we're back to the sync token. Bottom line, the sync token is pragmatic, it's battle tested, it works, it hides a lot of complexity, you get 99% of the use cases you need from it. It's not blazingly fast. You have to make the client do a lot of work. The requirements were it just has to stay up and work and do its job. So it does that. To zoom out to the full picture, thinking about product strategy, Google doesn't care about Google Calendar that much. It doesn't generate revenue. It comes pre-installed on Android phones. They're not making campaigns to get you to try it out. They just got to keep you from hating it so much that you try out Apple Calendar or Outlook. And for the clients to integrate with it, they have to just keep you happy enough so they can say, hey, you can do whatever you want, and give you the tools to do that without hand-holding. They're not going to have a client success team. They're not going to go crazy on the docs or the demos or the ads. However, I'm kind of defending them a lot. There is still a big gap between what a new developer would expect from the Google Calendar API and the reality. And we saw that with Cool Calendar and our friend who didn't get to go to Denny's because he had no way of knowing. Even if you're senior level, you're probably going to be too optimistic about how easy it is to have a production ready integration with Google Calendar, because they don't say this stuff to you. They just give you that little doc about synchronizing resources, and then they're like, well, they'll figure it out. You guys know it's hard, Google. You know it's hard, and you could at least give us a warning to temper expectations. Keep expectations low. You let them get too high. That's my spicy take. It's like you're leading us on, and I don't appreciate it. Okay. From Google to regular builders, I have takeaways. When creating an API, similar to Google Calendars, keep it boring by using existing standards. So they relied on CalDAV, iCalendar, and RUle, all open web standards. They could have rolled their own optimized versions of those tech, but they didn't need to. They're trying to make it easy, simple to extend, and I don't think it's any coincidence that a lot of people have integrated with Google Calendar but not with Yahoo Calendar, which didn't take that path. Next, cursor versus offset pagination. Rule of thumb, use cursor when the data is a moving target, like the event's changing a lot, and use offset when the data is stable. Think search engine with pages or an admin table for small data that you control, like a government system. There's a temptation when you're building an API and adding all this exciting stuff to hype people up. If it's a core part of someone's infrastructure, like Google Calendar is for every scheduling app since 2006, then don't hype it up. Don't hype it up. Let your main product do the marketing. You don't have to convince people, which leads me to my next section. Just don't break stuff. Don't break stuff, bro. If you're a foundational product, go slow. Spend time testing it. Test the migration scripts. Give users heads up in emails and terminal messages. It's accepting a different posture or identity from just the wily crackhead vibe coder to like professional disciplined team that does what's best for the clients. Even if you don't like a method name, going slower shows responsibility for your role in someone else's product. Google has done really well is they just haven't broke. I appreciate that. Don't overlook the power of just staying up and not breaking stuff all the time. Now, if you're consuming an API, which will be most cases, and you're starting a new product like Cool Calendar, don't start here. Don't start here. You'll say, well, my users won't use the app if it doesn't just make the app more differentiated or more unique to where they have no problems using a username and password, signing up with a magic link, or manually creating events from scratch. They did this with Google Calendar when they had accounts there because they knew it was worth it. If you can sell the app or position it right, that's where I would spend my time rather than jumping right into an integration. Integrations, not just Google Calendar, are 80-20. 80% of the work is on the last 20% of tasks. So many edge cases widen in the thick of it. You get so optimistic that it's just so simple based on some quick start guide, but it's not that simple yet. I hope one day shipping features and apps will get that simple where you can just plug and play your own way with integrations instead of having to use a different platform to do it. One final takeaway about life: simplicity for one party means complexity for another. If there's a simple UI, the back end probably doing a lot behind the scenes. If it's good for regular users, it's probably not so good for power users. If it's super simple a la carte pricing, probably a lot of complicated interviews and research went into R&D and user interviews and figuring out like what do you actually care about. And as we've seen, if there's a simple API, there's a complex integration. So next time, I think I'm just going to get this free API. It looks really straightforward. It'll be simple for me. I'm going to remember it's either free or simple. Someone always pays. Now, go get your pancakes. Enjoy.